Today we will discuss trigonometric identities. It is chapter 8, class 10. This is a trigonometric identity. It is also an equation, but such type of equations are called trigonometric identities. Now, what is an identity? A trigonometric identity like this is an equation, a special type of equation which is true for all values of theta. Now let us see. This is an equation, a trigonometric equation, sin theta equal to 1. This is true only when theta is 90 degrees. Sin 90 is 1, right? So for any specific value of theta, only then this equation is true. This is an equation. This is not an identity. But this equation is called an identity because it is true for all values of theta. Theta is of course between 0 and 90 degree, because in class 10 trigonometry we define the ratios sin theta, cos theta, etc. by assuming that theta is an acute angle. Okay, like this. This is an acute angle. This acute angle is theta. By taking any one of these acute angles as theta, we define sin theta, cos theta, etc. So theta lies between 0 and 90 degrees. Theta is an acute angle and theta lies between 0 and 90 degree. Okay. Now this relationship, this equation is true for all values of theta between 0 and 90 degree. Okay. So this such special type of equation, this is a special type of equation and this is called an identity. So an identity is a special equation which is true for all values of theta. So theta is defined like this, an acute angle. Theta is an acute angle. Okay. So whatever you put here, starting from 0, 1 degree, 2 degree, 3 degree, 4 degree, up to even for angles like 35.5 degree, 12.9 degree, etc. Means for all values of theta between 0 and 90 degree, this relation is true. So it is called an identity. It is a special equation called identity. Now we have several identities in trigonometry. So these are three core identities for class 10 trigonometry, and these identities can be proved. Though the proofs are not required in the new syllabus, but you can prove them. Let me show you how. Just for understanding, let me show you how you can prove these theorems. The emphasis is on practical application of these identities, not on the proofs. Okay. Suppose we have a right angle triangle. This is the acute angle theta. So this is the perpendicular, this is base, this is hypotenuse, right? So sin²θ cos²θ, we have to prove this one. Sin² plus cos² is equal to 1. What is sin²? It is p by h, and cos² is b by h, right? So sin² plus cos²θ, this is equal to p by h cos²θ b by h square. This is p square by h square So we have p square by h square, b square by h square. This is equal to p square plus b square by h square. So p square plus b square, p square plus p square, this is equal to h square, right? Why? P square plus b square is equal to h square. That is Pythagoras theorem. Remember Pythagoras theorem? Hypotenuse square is equal to perpendicular square by perpendicular square plus base square. That is Pythagoras theorem. So by Pythagoras theorem, this is equal to h square. So that means the whole thing is equal to, cancel it out, we get 1. So sin²θ plus cos²θ is equal to 1. So that is the proof of this identity. So similarly, the other identities can also be proved. Okay. But we are not going to do that because the proofs are not required. Only the application side is required. Only the application of these identities is the focus. How to apply these identities. That is the focus of the new syllabus for class 10. In solving problems from the trigonometry chapter, you will need trigonometric ratios and sometimes trigonometric identities. Okay? The problems that you will solve may need help of only trigonometric ratios or only help of trigonometric identities or a combination of both. You remember the trigonometric ratios? Sin² is equal to 1 by cosec²θ. Cos² is equal to 1 by sec²θ. We covered this in the last chapter. Tan² is 1 by cot², also equal to sin² by cos². Cot² is 1 by tan², also equal to cos² by sin². Remember these ratios? So as I was saying that to solve problems, sometimes the problems can be solved using one of these ratios or a combination of these ratios, or sometimes you can solve them using the identities, one or multiple identities only, or sometimes you may need both the ratios as well as the identities to solve problems. So let us see one example which requires the combination of trigonometric ratios as well as trigonometric identities. The first identity will be required here. So the problem is prove that sin theta plus cos theta tan theta plus cot theta sin theta plus cos theta tan theta plus cot theta cot theta is equal to sec theta plus cosec theta. Sec theta plus cosec theta. Okay. So this is what we have to prove, that sin theta plus cos theta plus tan theta plus cot theta is equal to sec theta plus cosec theta. So to solve this problem, we will need help of ratios. We will need take the help of trigonometric ratios as well as trigonometric identities like this one. So let us see how we can do that. So left hand side, this left hand side, this one, it can be written as sin theta plus cos theta. Tan theta is sin theta by cos theta. Sin theta by cos theta. What is cot theta? Cos theta by sin theta. Cos theta by sin theta. Right? Which is equal to sin theta cos theta, taking LCM, sin theta cos theta. It is sin square theta cos square theta. Right? Multiply sin theta, sin square theta, cos square theta, and taking the LCM, sin theta, cos theta. So this is equal to sin theta plus cos theta. And what is the value of sin square theta plus cos square theta? Sin square theta plus cos square theta? 1. So we replace the value here, then sin theta and cos theta. So the value we get here is sin theta divided by sin theta cos theta plus cos theta divided by sin theta cos theta, right? So we get, which is equal to 1 by cos theta. 1 by cos theta plus 1 by sin theta. 1 by sin theta. This is equal to 1 by cos theta. 1 by cos theta. Cos theta is 1 by sec theta. So sec theta is 1 by cos theta. So sec theta is 1 by cos theta. Right? So we get sec theta and 1 by sin theta. Sin theta is 1 by cosec theta. So cosec theta is 1 by sin theta, reciprocal. So we get cosec theta, which is equal to the right hand side, equal to right hand side. So this is proved. Similarly, there will be problems where you may need to combine trigonometric ratios with trigonometric identities to solve problems, or you may be able to solve problems by using just ratios or by just using identities. Okay, so we will cover more of that in the next class. We will do some more problems in the next class. Okay.